name is Buck Nye. I'm with HC&I Company. I'm the president. Today, we appreciate you all joining us for our 2020 fall seminar series, Improving Indoor Air Quality During Replacements and Retrofits. This is part 2. So the people that sat with us through part 1, we appreciate it. We do have a YouTube channel, HC&I Company, where we are recording all of our webinars for your use later. If you would like a link to that, you can hit up Jim O'Donnell, myself, or your local salesman that you deal with. We'd be more than happy to get that to you. So without further ado, I'm going to turn it over to Jim. Again, we appreciate you taking your lunch hour to be with us. And just a couple of housekeeping things. There is a chat box and a Q&A box down at the bottom of the screen. We would like to ask questions. We do that at the end, correct, Jim?
Yes, please, yeah.
So put your list of questions together and we will make sure that we answer them as we're going, and or wait till the end. So Jim, take it away.
Okay, thank you. Thank you, Buck. Just a couple other things is we have the ability to issue a PDH credit for 1.0 credits for this presentation. And also afterwards, like Buck said, I will send out a recap that has the link for the video, any other information that popped up between the presentation and those notes, as well as I will list the questions and then the answers that were provided from the presentation. So once again, thank you all for coming. My name is Jim O'Donnell. My contact information is there in the lower left-hand corner. And then just before we get started, want to thank my coworkers of Buck Nye, Sharon O'Reilly, Tim Green, Rick Aditis, as well as Jim McCoy. So let's get started. All right, so today's presentation is regarding dilution. There's going to be 3 broad categories that we're going to talk about. First one, just a quick IAQ overview, even less brief, or more brief than last time. There's 2 main parts. The first one is going to be to review the recent ASHRAE EPIDEMIC publications, where there's a building readiness as well as the schools and universities. In each of those documents, I'm going to emphasize the ability to increase outside air and review those implications. And then the third part is, if we're increasing outside air, I'm going to try to apply some real world or just some applications to help you folks as designers, engineers and owners, et cetera, regarding these systems and equipment that are listed there. All right. So quick, just indoor air quality. This is a partially repeat slide from part 1. Indoor air quality consists of 3 parts: filtration and source control, that we covered in part 1. And then the third one is dilution, that we're going to focus on today. Dilution, the definition is the action of making something weaker in force, content, or value. And then just can't help myself to be cheeky, but some bad examples of dilution obviously would be, an alcoholic drink where they water it down with alcohol. A pet peeve is when you go to a mall and you want to get some Chinese food. You see the picture on the above that has a big thing of the good stuff on there, and then when you get it delivered to you, it's all rice and you have a little dollop of the stuff that you wanted to order. And then the third thing that has to do with value is just the bull on Wall Street. Just once again, something bad that if you own stock in a company, you have a certain number of shares, and then they issue additional stock, the shares that you have owned have been diluted. Example I think recently was AMC Theaters. Okay, so in HVAC, a good dilution is when we introduce outside air to spaces, then that reduces the contaminants within the space. So HVAC equipment, here's a simple, very common diagram of an HVAC system. You have a rooftop unit on the roof. You're mixing outside air with return air. Inside of that rooftop unit, you have filtration as well as heating and air conditioning components to condition the air. That mixed air then travels down the ductwork to supply air, And then also too, we'll touch on just there is the also another red part of the air there that's exhaust or relief air that has to be worked in conjunction with the amount of outside air. All right. So repeating from part one, there are contaminants in the air that we breathe. There's two broad categories. There's aerosols and gases. Focusing on aerosols, aerosols are fine particles that are in the air. A subdivision of aerosols is microorganisms. These could be pathogens that cause disease, such as bacteria, and I've highlighted just viruses that obviously with the recent turn of events, everybody's interested in a specific virus. That specific virus is the SARS-CoV-2 that causes the COVID-19 disease. This is a repeat once again from part one slide, just how viruses spread. There were some other methods. The one that we're going to focus on today is airborne. In the upper right-hand corner is a person that's coughing or sneezing. If you look on the lower left, there's a large diagram. This was taken from like tuberculosis, but the infected person on the left then coughs or expels the viruses in different forms, and other people then get affected in the space or just coming into contact with these viruses. Just I've put once again a question about SARS and airborne. Just once again, as I said before, I've kind of tuned out all the information about the epidemic, but just the CDC originally said that it was spread by airborne methods, and then they said that it wasn't, and then I believe they said back that what it was again. All right, so part two, we're going to review the recent ASHRAE epidemic publications, building readiness, schools and universities. And then as I mentioned before, we're going to emphasize increasing the amount of outside air and reviewing those implications. All right, everybody's familiar with ASHRAE. Once again, repeat from part one. They've created an ASHRAE COVID-19 website. They've created an epidemic task force. The statement that they have generated is that ASHRAE's position is that transmission of SARS through the air is sufficiently likely airborne. Once again, trying to emphasize airborne. Exposure to the viruses should be controlled. And then changes to building operations, including the operation of HVAC systems, can reduce airborne exposures. So essentially, just ASHRAE has taken the position that your HVAC system can propagate or spread the new SARS coronavirus, the novel coronavirus. All right. Repeating from part one, those two documents, there's the building readiness that's over 100 pages. There's the schools and universities that's been changed to 43 pages. This I've crossed out, it's been updated a few times. For this presentation, I've based my information or just presentation based on the updates that are highlighted in red there. And then once again, this is a repeat. This guidance has been formulated to help designers retrofit and plan for improvement of indoor air quality and to slow the transmission of viruses via the HVAC system. Just wanted to highlight that ASHRAE is typically these documents are guidances. They are not codes. Additional or local and national codes have adopted some of ASHRAE's standards as code. Okay. And then repeating once again, the building readiness in schools and universities, not going to read these, but they do have a couple of broad different categories. What I want to focus on today is in the building readiness, they have specific recommendations. We're going to talk about increased ventilation today, increased filtration, which I've crossed out, which was done in part one. And then energy, number three is energy recovery ventilation systems, operating considerations. We'll talk about that in part three. And then building exhaust and air and reentrainment is very simple and basic. So once again, today's focus, I'm going to talk about increased ventilation, providing more outside air, and then replacements and retrofits. Part one may be slanted towards retrofits. I would say that today's presentation slants or just emphasizes replacement work. All right, so why do you want to provide more outside air? ASHRAE has created another guideline, 62.1, for ventilation for acceptable IAQ. This purpose that I've copied here to specify minimum ventilation rates to provide IAQ that is acceptable to occupants and that minimize adverse health effects. This was from version 2016. Once again, just anecdotally, everybody's aware of the positives of providing clean outside air to interior spaces and how that increases individual and people's health as well as their productivity, all right? So the most common method to calculate the minimum ventilation rate is 6.1. It's the ventilation rate procedure, short for VRP. It's a prescriptive design procedure. Once again, this is nothing new, but just the ventilation requirements are determined by your space and type of application, along with the number of people. You add in the floor area, give it a CFM per square foot. And then you divide that by its own air distribution effectiveness. This takes into account how the air is distributed or supplied and returned from your space. There's different categories or different factors applied for supply at the ceiling, heating at the ceiling, et cetera, like that. And then once again, this is a pretty common occurrence, or just everybody should be very aware of this. This outside air quantity is your per person plus your floor area and divided by that zone air distribution effectiveness. And then just to emphasize once again, this standard is calling for a minimum ventilation rate. But then today's topic, or just because of recent events, the ASHRAE is saying, okay, now we want to increase the amount of outside air to help prevent the spread of the virus. All right. So back to our epidemic task force, they've created that cool little icon in the upper right-hand corner there. Building readiness under epidemic conditions in place. We're going to focus on increased ventilation, and then in schools and universities, I've just highlighted the designer guidelines for general school. And then just sort of flip-flopping from part one. On part one with the filtration, we emphasized or worked more so in schools and universities. But for today's presentations, we're going to delve or just use more information from the building readiness guidelines. All right. So reading from page number 15 in the building readiness, for increased ventilation, encourages building operators to increase their outside air ventilation and reduce the recirculation air back into the space. But once again, they have a little catch-all or however, all right? So the next two sentences are just a snapshot from that guideline. The guidance indicates that this must be done as much as the system or space conditions will allow. And then one major concern is the ability to maintain space conditions. And then furthermore, in the guidelines, it talks about hot and humid climates. You could struggle to keep the space below your acceptable room temperature and RH for comfort. And then the opposite happens in cold climates. In cold climates, you could struggle to keep the space above acceptable temperature and RH for comfort. And then just for today, I want to not just say climates, but basically conditions. So it's not just, okay, we're in Philadelphia. We obviously have both conditions where we have hot and humid weather, as well as cold and dry weather. So then to visualize just what they're talking about for maintaining space temperature and RH, we're going to look at ASHRAE GIST 55, thermal environmental conditions for human occupancy. This is a very common slide or picture that's been modified or just shown over the years. This is taking a small snapshot from the psychometric chart. What they've done is in the hatched area, they're looking at, that hatched area is where occupants feel most satisfied for comfort conditions. They've borderlined it with 60% to approximately 40% or 30% RH, as well as our temperatures are in the 70 to 68 degree range, up to 80, 78 degree dry bulb. And then once again, just to emphasize, we have cooling would be more so up to the right, and then heating with the little snowflake is down to the left, right? So the standard or just the guidelines are saying, okay, if you're going to increase more outside air, you don't want your space conditions to extend past this nice, comfortable central area here. What they would like you to do is make sure your space conditions remain in this centralized or comfortable temperature and RH conditions, all right? So furthermore, in building readiness under increased ventilation on page 15, maintaining the space RH between 40% and 60% decreases the bioburden of infectious particles in the space and decreases the infectivity of many viruses in the space. Sort of a mouthful. But visualizing what they're talking about, this is once again a very familiar chart that I'm assuming most of you are familiar with. On the top, on the x-axis, it has the percentage of RH going from 10 up to 90. On the left or the y-axis, we have a bunch of different cooties or things that are not good for occupants. I've just highlighted viruses once again because that's what we're greatly interested in today. And then these red triangles are just trying to demonstrate or just show is that viruses, the larger triangle at your lower RH and higher RH propagate or just are more strong or just they're worse for human occupants at those conditions. And then once again in that green area here is you can see just most of these bad items are minimized when you maintain your space between 40 and 60 degrees. And then once again, just to kind of emphasize that typically on the left, heating we have difficulty maintaining RH. And then in the summertime when it's hot and humid out, we often have difficulty maintaining our RH low enough to maintain comfort conditions. All right. And then switching just to schools and universities, just to kind of reiterate, the document has two spots, the introduction as well as designer guidelines, where they talk about increasing the outside air and then also maintaining indoor comfort for your temperature and humidity. All right. So let's look at page number 15 in the building readiness. They've done a nice job of demonstrating an example of the what happens when you increase the amount of outside air in your HVAC system. This was done by the train office in Orlando, shout out to them, but they took they took a 10,000 CFM supply air handling unit that had a chill water coil. They kept the coil the same, they kept the chill water conditions the same, and then they based some calculations on maintaining a constant leaving air temperature of 52 degrees and 51.5 degrees dry bulb. Here's the chart that comes right out of the guidelines. On the left, you have your percentage of outside air. What they did is they started at 20% and increased it up all the way to 90%. Next is your entering air dry bulb. As expected, as you've increased the amount of outside air and reduced the amount of return air, our mixed air temperature rises. They've allowed the GPM to increase to satisfy that 52 degree and 51 degree wet bulb. With an increase in GPM, we have an increase in water pressure drop through the coil as expected. And then with the increase in GPM, you can see that the total capacity that's required to maintain that 52 and 51 degrees has increased. And then once again, just emphasizing what they've done is they've kept the 10,000 CFM the same and they've converted return air to outside air. So delving into further at the two lines where it's 30% to 40%, so they've ended up increasing the outside air by 33% while maintaining the leaving air temperature. This is just a blow up of it. I want to just show that as expected, as you add more outside air to your system, you have a warmer entering air temperature. There's an increase in necessity of your GPM, and then that higher GPM has a higher water pressure drop. So increasing the outside air and allowing the GPM or chill water to increase. This example here, they were able to increase their capacity by approximately 12%. If you do the math, they went from about 49 tons up to 56 tons. Now, instead of increasing the outside air, what would happen if we kept our existing chill water the same, but then increased our outside air? We're going to have a higher entering air temperature. So what I did was I took an Aeon DX coil, I inputted the higher water temperatures, and then inputted the output of cooling. And as expected, what would happen is that if with the lower capacity with more outside air, we are not able to maintain that 52, 51 degree leaving air temperature. So our new, higher leaving air temperature is about, 3/4 or 1/2 degree. And then once again, I just put approximately because I didn't have the actual program. It's approximately plus or minus 1/4 degree, in my estimation. So what would happen? Can you operate with a slightly warmer leaving air temperature? All right. So as we have introduced more outside air, as expected, we can, can you operate with a slightly warmer as well as moister leaving air temperature? And then this, once again, is during the cooling season. So some items to consider that you would have to evaluate: is this comfort or process cooling? What type of space is it serving? Is the cooling or for dehumidification purposes? And then what percentage of outside air currently is provided? If you're going from 20 to 30%, it's much different than going from 70 to 80. And then does the unit contain an energy recovery wheel? The use of an energy recovery wheel, as everybody is aware of, helps mitigate the energy consumption, and it helps minimize the temperature differences. And then also the number of occupied hours. And then the last thing is, what are your design conditions that you're using to calculate your load? All right. So when you do a cooling load evaluation, you also have to obviously perform this for your heating and dehumidification loads. Some considerations at your peak conditions. Once again, you're looking at maximum occupancy along with maximum internal loads, your maximum solar load, as well as your maximum dry bulb temperature. Some other things to consider: did you apply a safety factor? Did you apply a diversity factor, which would have reduced our cooling peak conditions? And then furthermore, just talking about your outside air conditions, are you using ASHRAE for cooling or design temperatures or dehumidification temperatures? And then once again, ASHRAE has a couple of different hours or percentage of hours to use. 2% with 8760 of hours per year. That's a maximum of 175 hours out of the year. And then just to emphasize, if you're using the 0.4 degree temperatures for your calculations, that comes out to about 35 hours per year. A little more than a full day. Maybe your peak load is obviously during the occupied summertime in the afternoon. So maybe this 35 hours translate, not just a day and a half, but maybe 3 or 4 days in the summer. All right. And then furthermore, just looking at 0.4 degrees for cooling for Philadelphia. Those are our wet bulb and dry bulb numbers. And then just, as calling on consultants, everybody has different office standards, use standards, et cetera, depending on their office standards, as well as what the application is used for. All right. So you've designed equipment in the past for 2 conditions. All right. Your minimum ventilation code, you're using 62.1 along with your design conditions. On the site chart that's shown there, apologize for my poor choice of colors, but that's like what is that, Rick? Like a purplish blue. But anyway, you're designing your load for your cooling load as well as your heating load in those approximate locations. And then you also have to consider your minimum operating conditions, all right? Minimum operating conditions are that grayish box there, where basically it's milder temperatures, and then just milder outdoor temperatures. And then also just to emphasize that these are the majority of operating hours versus the 0.1 where you're at your design conditions, all right? So now what the ASHRAE guidelines for the EPIDEMIC has asked people to do is now they've essentially asked for a third design condition where you've increased your ventilation requirements above your minimum ventilation code. So back to our site chart with our minimum ventilation code and minimum operating conditions, what the guidelines has asked is essentially the analogy is they've increased your outside air design conditions, and what will happen is that your equipment for cooling load will probably become even more oversized. So back to our 30 to 40% outside air, where we've increased our tonnage from approximately 50 to 56. And then the other thing that you have to now be careful of is this minimum operating conditions. Number one, once again, it's the majority of your operating hours. And then the other thing I want to assume or point out is that those minimum operating conditions are mostly the same load. where you have the same solar, you have a little bit different outside air, but it's pretty mild. And then your people numbers are probably essentially the same. So you just increased your difference between your peak load and your part load conditions. All right. What I'd like you to consider or try to do is try to minimize the use of on-off capacity control. That's shown on the left there. We would not like that fluctuation between our temperatures as well as our RH. If you add modulating capacity control, you can see you've increased the on operation and reduced the off operation. You would produce much more stable operating conditions, as well as space conditions. And then just Aon a few years ago did a study where they put a data logger in a space. They recorded the dry bulb temperature and RH temperature. The original equipment was DX with on-off compressors as well as hot gas reheat that had on-off control. As they measured the temperature over that 24-hour period, the dry bulb temperature had a set point of 70. The fluctuation of plus or minus 3 degrees is not really too bad or too uncomfortable, but just want to emphasize that for this study that they did, this test that they did, relative humidity with the on-off hot gas reheat control, as well as obviously the cooling from the DX system, had a very wide fluctuation. Just highlighted, plus or minus 14%, space at 60%, 74% relative humidity in the space is obviously very uncomfortable. And then once again, from the chart before, that's not a good spot to prevent the growth of mold, bacteria, and propagation of viruses, et cetera. All right. So what Aon did was they retrofitted that on-off system for the compressor with digital scrolls, where they added modulating. Hot gas reheat was also converted to modulating. They went back and recorded the temperatures once again over a 24-hour period. You can see the dry bulb temperature had a plus or minus of ½ degree versus 3. And the other thing that was probably even more beneficial is that the relative humidity had a plus or minus 5%, which made it much more comfortable than it was before. All right. So now we've gone through the recent publications. Let's talk about some real world applications where we're going to look at if we increase the outside air. Let's look at some system applications for replacement and retrofits. The first part we're going to talk about is rooftop units, and then we're going to meld in or just bring in terminal equipment. All right. So when when you have to replace, increase your outside air for replacement work, obviously you want to try to minimize your replacement costs, right? So there's basically 3 broad buckets of costs that you will be faced with. The first one in the upper left is something that I feel that you definitely have to do. You'd have to spend the resources and money for engineering, design, as well as project management. Obviously, you're going to have to spend the money to purchase the new equipment and then also rigging and setting. If you do this properly, hopefully you can minimize the amount of work that you have to do for reconnection work, where I considered it to be duct work, as well as insulation, piping and insulation, as well as controls. And then for today's presentation, what I wanted to try to emphasize or just give you food for thought is I was trying to minimize the impact that's associated with changes due to footprint, changes that due to weight. Obviously, if we have a large increase in weight, that would affect our structure. And then also too, increasing the size of our unit could also have an effect on our utilities, your gas and electrical service serving that equipment. All right. So the most common methods to introduce outside air into the space, the first one are packaged DX rooftop units. These can be with or without energy recovery wheels. Back to our simple slide here, or just a depiction showing a packaged rooftop unit. Once again, your outside air is mixing with your return air. That turns into supply air. Within the unit, you have filtration as well as equipment to condition the air, for your heating and cooling. All right. So there's 2 broad categories of packaged rooftop unit. The first one is considered to be, the name is unitary, where typically these are pre-engineered, and then just generally these are smaller in capacity, and then they offer less features and benefits, right? What we're going to talk more so about today is applied rooftop units, where obviously there's some of the information or items in there are pre-engineered, but they do have many more options available to customize for your application. And then generally they're larger in capacity. And then along with that customization, they typically have more features and benefits that are benefits obviously to your maintenance staff, your operations, your energy, et cetera, like that. All right. The second method for introducing outside air is a dedicated outside air system. The acronym is DOAS. Once again, this is with and without ERW. I just highlighted the word system because this is a unit as well as what I'll consider to be called terminal equipment. Terminal equipment examples are unit vents, fan coils, water source heat pumps, et cetera, like that. Here's a depiction of just a DOAS system. You have a unit on the roof. It's typically 100% outside air. Inside the unit, you have, once again, your filtration and your heating and cooling components. That outside air then gets distributed to the space. Usually the outside air is 100%, and usually that equals the return air. For the most part, there is not return air. Obviously some systems do. And inside the space depicted in red are your air terminal pieces of equipment. So a common design for the outside air is to pre-treat the unit. I put down makeup air, RTU, DOAS, just because there's a lot of different acronyms for this type of unit. It's usually designed so that the leaving air temperature produces neutral air, neutral in respect to temperature as well as humidity. And then another option would be to lower your leaving air temperature, where the air then becomes dry enough to provide dehumidification in the space, all right? And then along with the outside air, you have your air terminal equipment. Your terminal equipment typically is designed to satisfy the cooling and heating space loads. This DOAS system has decoupled the outside air versus your terminal equipment, all right? And then just once again, the makeup air, DOAS unit are typically applied. The benefits are with their pre-engineered plus customization. And then once again, they have a wide range of capacities available as well as features and benefits, right? So back to our rooftop units with our unitary rooftop, as most of you might know, I used to work at Carrier. Carrier has many different rooftop model numbers, but most manufacturers offer a range of rooftop unit sizes where they have the same footprint. Looking at Carrier's number 48HC, the range is from 3 to 25 tons. The HC product has been around for a number of years. Obviously it's undergoing iterations with improvements for options and features as well as capacity. As well as energy efficiency. And just so I created a chart where I took the units that had the same size with the same footprint. From the catalog, found out the approximate base weight of the unit, what the natural gas service was, as well as your approximate electrical service. So the 3, 4, and 5 were the same, 6 through 10 were the same, and then just wanted to highlight the 17 as well as 20-ton Carrier HC rooftop systems. These had the same footprint. If you had a 17.5-ton unit and changed it to a 20, you'd be able to realize a 14% increase in capacity. Just highlighted, there's a little bit difference in the base weight. They have the same natural gas inputs. And then, there's a range of electrical options available in terms of like GFIs and motor horsepowers, but I just looked at the range of MCA and MOCP. As you can see, the numbers are relatively close together. All right. So focusing on the applied rooftop unit, HC&I represents AAON. AAON has been around since 1991. Just some facts to tout their awesomeness. So from the 2019 report, annual report, they had $470 million in sales. Always flabbergasts me, like the amount of units that these manufacturers or just any manufacturers make, but just they had 26,000 total units, 14,000 of them are RTUs. I think that comes out to like 7 units an hour or something like that. And then just obviously being in sales, we always like to see manufacturers spending or investing in updates with research and development. Just AAON, had a healthy $14.7 million that was spent in 2019. And then along those investment items that we in the field are happy with, AAON a few years ago created or built the Norman Asbjornson Innovation Center. This is an advanced testing center. It's like 135,000 square feet, located in Tulsa, Oklahoma, next to one of their 2 manufacturing plants. And then I just wrote a note to myself with some short acronyms, but they do offer factory witness testing for a rooftop unit, which is often unusual. They have a bay that can accept up to a 300-ton rooftop unit. And then the other thing that was cool when we went out for the grand opening is that they have an environmental chamber where you put on a snow jacket and gloves and you try not to fall, but they can make it snow inside as well as rain. And then just also touting, HC&I has been around since 1977. We have 2 locations, and then we're not just selling equipment and running, we're providing support from the conceptual design all the way through owner training. Once again, we're not just selling equipment, we also can provide service, warranty, and parts. We have 2 parts stores. There's a picture of the one here in King of Prussia. We do stock AAON parts, replacement parts, for the convenience of our customers. And then just from AAON's applied rooftop units, they have 3 model numbers, 3 broad categories. I put R2Us because they can be used for DOAS unit, makeup air, et cetera, like that. The RQ is from 2 to 6 tons. The RN is from 6 to 140. And I've highlighted the RZ unit that was previously an RL unit. In the past couple months, they've introduced the replacement for that. It goes from 45 to 240 tons. There was an article in the one of the trade publications, the News, a few weeks ago or so on that. And then just a teaser, eventually in the probably the spring or so, I'll put together a lunch and learn similar to this about the benefits of using large package rooftop units. All right. So AAON's applied rooftop units have a wide range of sizes using the same footprint, using the same chart as before. Just on the left, the RQ is from 3 to 6. The RN has 5 different cabinets, not to read through each of the different numbers, but each of those cabinets have multiple sizes available. Once again, just going to say there's too many variations for the base weight as well as the electrical service based on all the different options you can change. And then once again, natural gas, they end up standardizing on certain sizes. That's probably primarily done for AGA requirements, right? So exercise number 1 with an applied rooftop unit using the same footprint. This is a recent project that I worked on that was in design phase. We had a rooftop that was going to be used for VAV with an airside heat pump as well as electric heat. The initial design conditions were the numbers on the top. I had to use a size 20. Then the engineering came back and said, oh no, I need to increase my outside air and supply air. So we increased those numbers and we had to increase to a size number 25. Now the good thing is that the 20 and the 25 are the same box size. So I've taken the same chart as before where I had the operating weight, the heating capacity. I've added just the cooling capacity as well as the supply fan and then the electrical service, all right? So increasing the from a 20 to 25 with the same footprint, I was able to provide almost an additional 30% additional cooling, all right? Now, 2 things that I consider to be attractive or nice is that the operating weight went up a little bit, and then the electrical service also went up a little bit. So maybe with those small changes, you'd be able to not have to redo your structure or redo your electrical service feeding the unit. All right, exercise number 2, using the guidelines of a 30-40% from building 15. I converted we're converting the return air to outside air. I changed the chill water to a DX with rooftop. I changed the location. I kept the same supply air CFM. and then I'm designing or selecting equipment to provide a leaving air temperature less than a 55 and a heating temperature above 90. All right. So for this example here, to increase from 3,000 CFM, I had a size 31. To provide 4,000 CFM, I required to have a size 40. Once again, to emphasize, these are the same footprint, use the same items as before, or same items on my chart as before. For this time, I increased, with the same footprint, I was able to increase my cooling 17%. Once again, not too much of a change. Yeah, obviously on the weight, the electrical maybe is a little bit questionable. And then just want to now also point out that keeping the same gas service as before, my leaving air temperature changed from 95 to 89, which, you know, I probably would consider that not to be an issue. All right. So replacement work for that was previously on rooftop units. Now we're talking about DOAS units. Once again, trying to minimize the impact, but just the DOAS unit becomes more complicated for two reasons. Option one, if you're increasing your outside air, I would consider that your existing ductwork and air outlets are now undersized. I would probably consider that those are typically too costly to replace. If that's the situation, you have to be concerned about noise, and then also with your turn down capabilities. Option number two, if you're reusing existing, you still have the same supply air problems as on the left, but now you have some other considerations to think about. Your coil face area isn't too small. You obviously want to keep that below 500 feet per minute to prevent any moisture carryover. The higher airflow is going to have a higher air pressure drop. Is your fan motor large enough? Your supply air is going to be warmer. Your cold air, your winter cold air is going to be colder. Are those okay? And once again, you have to just be concerned or just cognizant of your controllability. All right. Okay, so replacement exercise number one for a DOAS unit. I've added an energy recovery wheel. I've made it location in Philadelphia once again. I've increased the exhaust air to keep 100 CFM differential. These are my entering inputs for my supply air static pressure. For the AON unit, I originally had a size 13 to handle 3,000 CFM. Now I need a size 15 for 4,000 CFM. Went through the same items in the chart as before. Once again, to highlight with the increase, the same box size or footprint, I was able to increase my cooling capacity by 21%. These are the differences in the weight is very small. My electric is small, but then the one thing that I thought was troublesome was that my gas service should probably be increased once again from 195 to 292 MBH. Once again, I felt that should be increased, you know, so my leaving air temperature, you know, to keep it above 90. So once again, there's something that you would have to obviously, all these items you would obviously have to evaluate. All right, so back to our DOAS unit. So instead of replacing, we're going to reuse the existing with more outside air. Same as before with the size 13. I've increased the outside air from 3,000 to 4,000, also the exhaust air. And then just figuring that I'm going to keep my same air distribution system. So therefore, I have to increase my static pressure for my two air streams. I figured to increase that by a half of inch static. So looking at the two selections, you know, same size. Instead of the cooling and heating output, I looked at the heating leaving air temperature and the cooling leaving air temperature. What has happened is that with the additional CFM as well as the additional static pressure, I'm going to require a larger supply and exhaust fan. That larger supply and exhaust fan you can see as increaser MCA. That's obviously not probably not a problem. Just want to emphasize once again that our heating temperature has reduced, leaving the unit, and then our cooling temperature has increased, all right? So just once again, as an evaluation, I would consider that it's much cheaper to reuse the existing unit, replace motors, but then once again, can you live with this in the cooling season, having warmer and more humid air being distributed to the space, and then your heating, obviously having colder air coming out at 70 degrees versus 97, all right? So along with reusing existing, what about our terminal units that are serving the space, all right? So our DOAS system capacities has decreased. Let's increase the capacity of our air terminals to compensate for that. HC9 represents Naylor for fan coils and Magic Air for univents. These are among, just some other manufacturers. Typically on fan coils and univents, you end up with the same dimensions for multiple sizes. Some of them are floor mounted, so it wouldn't be as treacherous to replace. And then typically there's not much differences in weight as well as electrical service, all right? So a better candidate versus having to upsize your hydronic system, I consider a better candidate would be to have a water source heat pump system where we're going to replace our terminal units. Just typically water source heat pumps with their central system utilities are often designed with diversity in mind. They typically transfer energy from the core to the exterior depending on the time of year and vice versa. And then typically a coaxial coil in these small units that are shown on the right, there typically is not much a derate as you change your fluid temperatures as well as your water flows. The other part with water source heat pump is, once again, inherently they're indicative of replacement work. They're designed with replacement in mind. Most of the times, or almost all the times, they have hose kits to be easily disconnected. The units have multiple fan speeds where you probably would not have to change your ductwork. A 3-ton unit at high is approximately the same as a larger 4-ton unit for its run at medium speed. And then also with that replacement work, you could add hot gas reheat to provide additional humidity control, all right? And then once again, the water source heat pumps have the same features as the fan coils in terms of dimensions and not many small differences, right? So AAON has a water source heat pump available from 2 to 230 tons. The model that I'm going to focus on today is the small vertical and horizontal unit that go from 1/2 to 30 tons. While you're replacing them to increase your capacity, you could also consider improving your indoor air quality by upgrading your filters, and maybe adding, once again, hot gas reheat. They have a unique design where there's an aluminum cabinet for lightweight corrosion protection. They have an aluminum microchannel for your evaporator coil. That larger face area results in smaller motor usage, smaller motor horsepowers. And then, as everybody's familiar with, microchannel typically has a lower refrigerant charge versus the traditional copper tube aluminum fin coils. Another unique feature is shown with the picture on the right, that they have bottom service access available. And then additionally, you could also upgrade to provide more energy savings with EC motors. They have a factory installed free cooling control valve, and then also a 2-step compressor, all right? So back to our rooftop units from application considerations. Just want to try to emphasize once again that those minimum operating conditions to provide modulating capacity control. So from an air flow perspective, provide VFDs or EC motors, provide multiple smaller fans. From a heating, provide the necessary staging if you have electric or gas heat. And then for DX cooling, instead of on-off operation, there's all these different options available for additional modulation, all right, for your cooling as well as hot gas reheat, all right. Other applications, improving IAQ, the AAON rooftop units, the larger RN sizes have a 2-inch double wall. They have low leakage as well as low heat transfer. You can get them, the interior painted for corrosion protection, upgrade your filters, and then obviously providing easier maintenance would result in better indoor air quality, all right? Controls available would be DDC, upgrade to DDC, upgrade to BACnet, and then reduce energy costs, once again, upgrading with energy recovery devices, VFDs on compressors and fans, and then you also can provide low leak outside air dampers. That last item is a minimal change. And then just once again, replacing existing units, you have to consider that a curb adapter. Is it changing the additional weight? Is that causing structural problems? You would have additional air pressure drop. And then also too, we had a project, previous work life, where adding a curb adapter made the unit too tall, and that became an issue with the local code. And then obviously adding a height to a unit like that, you have to consider your serviceability. And then if you do have to provide a duct adapter, a curb adapter rather, You want to minimize your transitions. You want to line up the supply air as much as possible. A trick of the trade is to use the return air as the adapter curve. Use the adapter curve as a return air path, return air plenum. All right. Next, we're going to talk about pressure and airflow measuring systems. Back to the building readiness, they have a building and space pressure section. Back to our rooftop unit, I just want to emphasize you're bringing in outside air. There's often exhaust air where your space can be positive or negative. The standard paraphrasing says if you're increasing your outside air but keeping your exhaust or relief air the same, you could cause potential problems with doors, noise, and then the other one to highlight is modify or even reverse the intended pressure required for space or spaces. All right. Additional paraphrasing, excessive building and space pressurization can also affect areas that are tended to be negatively pressured, such as process area, which kind of confused me. I looked at the standard and said, okay, they're probably referring to nurse's office, student health facilities or locker rooms. They're also mentioned bathrooms and then commercial kitchens. Just to tout a coworker, on December 8th, we're going to have another webinar on kitchen ventilation design. HCNI represents Paragon Controls. They are not just pressurization measurement and control company. They also provide airflow measuring. And then once again, it's not just for commercial HVAC. There's all these other applications that it's available. Their products are available for new construction, replacement, et cetera, et cetera. All right. Paragon Controls has been around a long time, established in 1984, right after I graduated high school. All right, so they're using pitot tube technology. This is the most recognized industry standard, the most trusted primary instrument for accuracy, et cetera, et cetera. And then it does offer the least amount of maintenance versus other systems. All right. And once again, I want to emphasize that they're providing systems. They have all these different components available. Just to emphasize, they have a 250-page master catalog where they have all these different tools and meters and monitors and devices available. A couple pictures there in the right center. All right. And then also too, for systems, all their products are industrial grade. They're ISO certified. And then once again, they're not just providing systems, they're providing a single source responsibility. They have all the design and manufacturing done in-house. They also have a team for engineering and design support. From my perspective, love that I can call somebody and talk about the selection application and then also integration, not just with the controls, but also with the HVAC equipment. And then further with the single source of responsibility, they have factory service personnel. We have locally trained personnel. They provide all these field services listed down there. All right. Coming to the last couple slides here. Increasing outside air energy recovery. I tried to make the text a little bit smaller, just because I'm not really going to talk about this today. Just running out of time, obviously. We'll try to cover this in part number 3. But just for replacement and retrofits, there's a lot of different information or different systems that are available. There's multiple manufacturers. Apologize, I haven't listed every single energy recovery device manufacturer that HCNI does have available. There's multiple types. We have shown here just a energy recovery wheel, which is probably the most common. Recent years has been a fixed plate with sensible, and then also implementation of total enthalpy. There's a runaround loop shown, small on the right there, and then the other one is a refrigerant-based heat recovery system. And then once again, because we're talking about energy recovery, we'll obviously delve into the ASHRAE standards that are associated with it. All right. So my summary, part 1 is the epidemic task force. They want to use the HVAC system to combat the spread of SARS-CoV virus. They want you to introduce more outside air to increase their dilution effect. But then while increasing that outside air, they don't want to cause temperature, humidity, or space pressurization problems. All right. So part 2, what happens if you increase your ventilation, the amount of outside air? You've essentially added a third design conditions. Called it today increased ventilation requirements. You've oversized or just increased the size of your equipment, and then oversizing that equipment, you have to just be careful. It could be detrimental when operating at your minimum operating conditions Obviously, once again, those minimum operating conditions occur for the majority of your operating hours. And then just a couple of examples of ways to minimize the impact of the increased outside air. When selecting an outside air equipment, whether it's an applied rooftop or a DOAS unit, you might want to consider one that has multiple box sizes at different capacities. Always want to emphasize that you should provide modulating capacity control to help reduce any fluctuations in the comfort in the space. I looked at, if you had a DOAS system, considering upsizing your terminal equipment. Terminal equipment, once again, was fan coils, UVs, water source heat pumps, etc. And then once again, another item that we'll talk about in the next presentation is adding energy recovery, right? So now here's our last slide. Just want to, once again, thank you all for attending. Hope these are worth your time. I feel like you probably get inundated with a lot of requests. I just want to show once again, or just remind myself, that we do have 1.0 PDHs available. Please email me if you require that. I can then email you a certificate. And then part 3, we're going to be hosting on Thursday, November 19th. I know some of you have already signed up for that. Thank you. And then we're also going to have in December, kitchen ventilation design. All right. So now at this time, let's open it up to questions.
So first question is, do you think the focus will move to air cleaning as opposed to dilution going forward to keep energy use under control?
That's a, I guess my opinion would be, I guess my opinion would be is that, typically first cost or replacement cost are the main driving factor for most projects, most, work that is done. Filtration, would say obviously because of the epidemic that recently occurred has taken more of a priority, and I would say the energy usage has taken a backseat. But then once again, just the standards for this guideline is not laxing or giving you a pass to not satisfy energy code requirements. All right, not sure if I answered that so properly, but okay. Next question that I can see is there any economizer impact? I would say that on on package, I would say this question mostly applies to package rooftop units. I would say just kind of thinking out loud, I'll probably maybe revisit this, but if you're increasing your outside air quantity, I would say that the when you have a larger outside air quantity during economizer mode, you would be providing additional free cooling. How that on the high end, I would think that your outside air is still considered to be too warm or too moist to really change that. On the opposite side, where colder air, if you have more outside air, you might have a situation where previously, once again, it depends on your internal cooling loads, but with the increase of outside air, you might have a situation where before you would, be able to provide free cooling with 40-degree air. Maybe with the higher outside air, you therefore would be able to provide free cooling with 35-degree air. All right. Okay. Next is, what type of humidification options do we have in this type of equipment? Are we limited to duct-mounted humidification? Okay. I would say, so the 3 products that we talked about, or 2 products would be Unitary rooftops or applied rooftops. Obviously, unitary rooftops, this is a bad candidate to add humidification. I would say just generally for applied equipment, because there's so many variables, you might have a situation where you do have space inside for, to add a humidifier. I would say that a humidifier typically requires obviously a drain pan underneath it. And then the airway length is probably in the range of, I've seen 12 inches up to 48 inches. Obviously, the larger capacities result in a longer airway length. And then just generally would say that the larger your system or larger your equipment, you would have a better opportunity to add humidification versus a smaller piece of equipment. So an example just off the top of my head would be like a 70-ton unit versus a 15-ton unit.
If I could chime in, that's all depending on the layout of the type of equipment. So if you're in a bigger built up type packaged unit or chilled water, hot water air handler, it's more appropriate to find a place for the humidifier inside the package system or the built up air handling system. So something small would definitely have to go to the duct. We got another question, Jim. Looks like we got two more.
Okay. Next question is, large portfolio owners have dozens to hundreds of AHUs to deal with. Performing individual engineering analysis on each AHU's heating and cooling coils is tedious and time consuming. What do you feel is the basic needs of these owners? Yeah, I'm not sure the intent of the question or how to, the direction to take on this. I would say, obviously today's presentation about the ability to increase your outside air has many ramifications in terms of increasing your cooling load, your capacities, your size of equipment. There's associated changes or potential changes to your structure, your electrical service, your utilities. Going back to part one, a better solution might be to provide global plasma solutions. This is a needlepoint dipole ionization, air cleaning product, I will call it. That from part one, we spent a lot of time just trying to demonstrate that adding GPS is less cumbersome than going through increasing filtration, and then also for part two, obviously adding GPS, to clean your air would be advantageous than trying to improve the amount or increase the amount of outside air. And then just one thing I will comment on is that global plasma solutions, GPS that I'm calling it, has been around for a number of years. I would say that their main, before COVID occurred, their main focus was on energy savings by once again reducing the amount of, cleaning the return air, cleaning the space, and reducing the amount of outside air. So once again, the GPS product might be, a better solution, to this question versus increasing your filtration as well as increasing your outside air. I guess for this question, Buck, I would kind of encourage whoever wrote this to contact yourself or me or your salesperson, and we can, talk about this further.
The last one is comment. It would be great if AAON could add humidification as an option. So there are specific sizes in the AAON family that we can add a humidifier. We would be looking at the RZ, which goes from 45 tons up to 240. And we have the RNA horizontal rooftop unit, which we can do an extended discharge. Instead of being a down discharge, it would be an end discharge. And we can extend that and put in a drain pan and a humidifier grid in that particular unit. And that goes from 9 tons up to 30 tons. It's, I don't know how many people have had familiarity using the AON RNA horizontal, but you know, it's pretty flexible, and it does give us the opportunity to stick in either final filters or a humidifier at the discharge with a drain pan. There are some limitations. We can't do a humidifier and final filters in that unit, but we can do a humidifier in those specific sizes. So just food for thought. I believe that is all we have as far as questions. Is there anything else before we?
I think that's it. You know, if obviously any other questions pop up, I've emailed just everybody, you know, my contact information. So feel free to email me. You know, any questions, as I said before, any questions that do come up, I'll summarize and then type up my reply. And then I'll say that I'll offer or just reserve the right to, you know, modify my responses a little bit or just add additional information. You know, try to be, you know, helpful, try to be transparent about what we're doing here.
All right. Well, once again, thank you all for joining us. Our next part 3 will be, what's that date? November 19th?
Yeah, Thursday, yeah.
And then
not Thursday, and I think in part 1 I put Thursday, Thanksgiving. So, you know, don't be ready to do some at lunch that day with me.
okay. Yeah, so we have that one coming up, and then December 8th, we're venturing into kitchen design best practices. So thank you again. It was great to host all of you, and look forward to working with you in the future and seeing you at our next seminar.
Great, thank you. Thanks, Bob.
Thank you. Great job, Jim.
Thank you.